Dear students, now we are going to see the course Signals and System. Under that the topic is Properties of Laplace Transform. So the course outcome is on completion of the properties of Laplace transform, the students will be able to get an idea of power series method to solve the differential equation, familiar with the Legendre equation and Legendre polynomial, understand the Laplace transform, learn the complex numbers and their properties. Properties of Laplace transform: linearity. If x of t, the Laplace transform gives x1 of s with the region of convergence is denoted as R1, and x2 of t, the Laplace transform is x2 of s with the region of convergence denoted as R2. Then a x1 of t plus b x2 of t, Laplace transform gives a x1 of s plus b x2 of s with ROC containing R1 intersection R2. Proof: the Laplace transform of x of t, that is equal to Laplace transform of a x1 of t plus b x2 of t is equal to integral minus infinity to infinity a x1 of t plus b x2 of t into e power minus st into dt. Multiply e power minus st inside. So a integral minus infinity to infinity x1 of t e power minus st dt plus b integral minus infinity to infinity x2 of t e power minus st into dt equal to a x1 of s plus b x2 of s. Time shifting property: if x of t is Laplace transform as x of s with ROC equal to capital R, then x of t minus tau Laplace transform as e power minus s tau x of s with ROC capital R. So Laplace transform of x of t minus tau is equal to integral minus infinity to infinity x of t minus tau e power minus st into dt. You make an assumption t minus tau is equal to p. So integral minus infinity to infinity x of p e power minus s t is replaced by p plus tau into dt. So e power minus s tau is constant. So e power minus s tau integral minus infinity to infinity x of p e power minus sp into dt, that is equal to e power minus s tau x of s. Shifting in s domain: x of t Laplace transform is x of s with ROC R capital R. Then e power s naught t x of t is e x of Laplace transform gives x of s minus s naught with ROC equal to R plus real part of s naught. Proof: Laplace transform of e power s naught t x of t is integral minus infinity to infinity e power s naught t x of t e power minus st into dt. Combine the e power exponential term. So integral minus infinity to infinity x of t e power minus of s minus s naught into t into dt, that is equal to x of s minus s naught. Time scaling: Laplace transform of x of t is x of s with ROC capital R. Then x of a t Laplace transform gives 1 by a x of s by a with ROC equal to R1, that is equal to a into R. Here the first condition is the value of a should be greater than 0. Laplace transform of x of a t is integral minus infinity to infinity x of a t e power minus st into dt. Using substitution, delta equal to a t and lambda is equal to a t, dt equal to a into d lambda. So 1 by a equal to integral minus infinity to infinity x of lambda e power minus s by a into d lambda, that is equal to 1 by a x of s by a. Case 2: for a is less than 0, Laplace transform of x of a t integral minus infinity to infinity x of a t e power minus st into dt. Using the substitution, lambda is equal to a t, dt equal to a into d lambda. Substitute this substitution in the Laplace transform of x of t, that is minus 1 by a integral minus infinity to infinity x of lambda e power minus s by lambda into d lambda, that is equal to 1 by a x of s by a. So combining these two cases, x of a t Laplace transform gives 1 by a x of s by a with ROC R1 equal to a into R. Conjugation. X of t Laplace transform gives x of s with ROC capital R. X conjugate of t Laplace transform gives x conjugate of s conjugate with ROC capital R. X of Laplace transform of x conjugate of t is integral minus infinity to infinity x conjugate of t e power minus st into dt. Here s is equal to sigma plus j omega, that is equal to integral minus infinity to infinity x conjugate of t e power minus sigma t e power minus j omega t into dt. Integral minus infinity to infinity x of t, the conjugate is taken into whole conjugate, x of t e power minus j sigma t e power j omega t into dt, the whole conjugate, that is equal to integral minus infinity to infinity x of t e power minus of s conjugate, integral minus infinity to infinity x of t e power minus of, combining both the term, sigma plus j omega into t into dt, the whole conjugate. Now this sigma minus j omega as conjugate of s, so this term can be written as integral 0 minus infinity to infinity x of t e power minus s conjugate of t into dt, the whole conjugate. This can be written as x conjugate of the whole conjugate, that is equal to x conjugate of s conjugate. Time differentiation. Laplace transform of x of t is x of s, then Laplace transform of dx of t by dt is s into x of s minus x of 0. Here the x of 0 is the value of x of t at t is equal to 0. Time integration. Laplace transform of x of t gives x of s, then Laplace transform of integral x of t dt gives x of s by s plus integral x of t dt at t is equal to 0 by s. Initial value theorem. The time limit t to 0 x of t equal to limit s to infinity s into x of s. Final value theorem. Limit t to infinity x of t equal to limit s to 0 s into x of s. Quiz question. What is the Laplace transform of the delayed unit impulse function del of t minus 1? Answer is exponential of minus s. Thank you for watching.